test that day, remember? No, I did, seriously.
Wow, your hair looks so long.
No, but it wasn't on this, it was like F or G and stuff like that.
Trick, here we go. Unit circle, boom, it's like this.
Wait, slow down, you're already going too fast.
You got your XY coordinates, talked about this, you got your circle with the radius of 1.
I'm not recalling that. Dude.
And
Dang, my circle was perfect.
it's pretty good. If we draw an angle in standard position, that just means you're going to start with your initial side down here. And we're just going to draw an angle, I don't know, say it right there. And I'm going to create a right triangle. Alright, so here are my vertices.
Oh my gosh, so do we do like, are we using SOHCAHTOA in calculus?
Yes, we are.
Oh my.
I actually kind of like that.
This is just
I
like
understand it.
pre-calc stuff here. Don't get too excited. But yeah, SOHCAHTOA is here, definitely. So if my angle is here, my angle is theta.
Wait, how do you say that?
Theta?
Like TH?
T-H-E-T-A.
I always thought it was with an F.
Theta?
Theta?
Feta? Like the cheese?
Double T.
F-E-T-T-A.
Theta here.
Bless you.
Can you tell me what the sine of theta would be? Well, you don't really know because you don't know how long you don't know how long. What's sine? Well, let's just start there. What's sine? Well, opposite over hypotenuse. So opposite, whatever how long this side is. Well, wouldn't this side, wouldn't the length be, if I know the coordinates of that point, or x comma y, how long is this side?
Why?
Y. Yeah, this is y, and this is x, right?
I thought the hypotenuse is x. So you're using sine.
No, x goes this way, y is this way.
Oh.
How long is the hypotenuse?
XY squared.
X squared plus y squared?
Wait, how long is the hypotenuse?
Yeah,
Yeah, x, y,
x squared plus y squared.
yeah, divided squared.
Equals
Yeah.
It's the square root of x.
Yeah,
But, I told you this was the unit circle.
so it's 1.
It's 1. The radius of the circle is 1.
Wait, that's not the radius, that's the...
That is the
So-
radius. It's to the
Oh,
outside.
The
yeah,
sine
okay.
of theta is y.
So the sine of theta is what?
Y.
That is correct. It's y.
Y over 1 is y.
Because y over 1 is 1, yeah. This is why we chose the unit circle to have a radius of 1. Because now the cosine of theta
Is y, is x.
is x. What's the tangent of theta?
X over y.
1 over y.
Neither.
Y over x.
Y opposite over adjacent.
Oh, duh.
Y over x. And there are some new ones that I don't know if we've talked about.
What?
No.
Besides sine, cosine, and tangent.
No?
That's not cool, man.
There's cosecant, which is abbreviated CSC.
That's not on my calculator.
I saw that on the SAT.
There's secant, which is SEC. And then there's cotangent.
Cool.
They're just the reciprocals of their friends here. Cosecant's the reciprocal of sine. So what's cosecant of theta?
1 over y.
Secant of theta
1
1
over
over
x.
x.
and the cotangent of
X
theta.
over y.
Just to jog my memory, what does reciprocal mean? Just
The opposite.
That's why I said I didn't give you any more hints. Yeah, you flip the fraction.
okay. I'm like, what the hell does that mean?
So knowing that, we can find the 6 trigonometric values, I guess. I'm not sure how to say this. Values. If theta equals pi over 3. So this, I'm just saying, if you know your angle's pi over 3, what's the sine of pi over 3, the cosine of pi over 3, tangent of pi over 3?
Wait, what?
We're going to find all these values if our angle is pi over 3. Pi over 3 is an angle, right?
So it's like plugging it in.
You could plug it into the calculator, but it'll give you a decimal. It will help. You'll need to remember, we always got confused a couple years ago. Cosecant and secant. Like, is secant the opposite of sine, or is cosecant the opposite of...
They're the opposite of each other.
Yeah,
That's
they're
the C and
the
C.
C goes with this S and the S, C, yeah. I shouldn't say opposite, that's not technically correct, but whatever, good enough. Cotangent, that's easier to remember. So we're going to find those 6 values. And it's
Why is it
easy.
still pi over 3? Is it 3 over?
No, the angle's the same.
Oh.
Our angle is pi over 3, so now we're going to find all.
Answer will be.
Our answer will be,
Okay, I get you.
so the sine of pi over 3.
Oh, what am I writing?
So instead of theta, it's
If-
pi, okay.
If you do it on your calculator, you have to make sure you're in radians. So we need to learn how to switch our calculator.
Oh, it's in mode.
Back and forth. Yep, mode. Right now mine's in degrees. I'll just highlight radians and hit enter.
No.
If I do sine of pi divided by
I
3,
push enter and it doesn't do it.
0.866, not very useful. What?
Wait, you know what? Math?
Mode.
Mode.
You're in radians. It's already highlighted.
Oh. Oops. Yeah.
So calculator, not that useful for this. 0.866 sucks. Here's what the answer I want to see. Go to your unit circle. Eventually you'll memorize it. Yeah, here's pi over 3 here. So it's like a 60-degree angle. The sine of pi over 3 is just the y coordinate. It's root 3 over 2.
Where did that paper go?
Imagine a triangle right there. This point is right here, so this side length right here is the square
So
root.
this is all memorization. This sucks.
Kinda is. Well, there's special right triangles in here. Remember special right triangles? 45, 45, 90, 30, 60, 90. It's all special right triangles. Because on a 45, 45, 90, the two legs are the same. That's why these are root 2 over 2, both of them. And we can talk about that. Talk about ways to memorize it. But yeah, for now, just look. You look at pi over 3, the sine is root 3 over 2. Can you do the rest?
Cosine is 1/2.
Yeah, looking at it, I can.
Well, yeah, look at it. You don't, I don't expect
So
you
is
to
the
have
other
it
one 1 over
memorized.
2?
Huh? Cosine is 1/2.
So tangent would be
You're
the
going to have
square
to do a
root
little work,
3 over 2 over 1 over 2,
which is not an acceptable answer. So
which is,
Square root of 3 over.
what's the
Just
square root of
multiply
3?
I'll leave it in there.
Wait, how do you know which ones to use?
3, the square root of 3 plus 1 over 2.
Oh, it's not. You're advanced farther than me. Where are you confused?
I said, how do you know which one to look at
Look
for
at that paper.
the cosine, tan, and all that?
Okay.
Well, right there.
Sine of the angle is the y coordinate of the point around the circle. So when you're doing the sine of pi over 3, you just, this point is this right here, 1/2 comma root 3 over 2. So like if I were to actually draw, I don't want to draw my next
We're in
answer.
October.
If I were to actually draw the triangle,
I grabbed it. I was like,
this point is 1/2 root 3 over 2, which means this side is root 3 over 2. This side is 1/2. That side's 1. So the sine is opposite over adjacent, it's just root 3 over 2. The cosine is adjacent over hypotenuse. Or I said opposite over adjacent earlier.
So the 10.
So the cosine, you're just looking at the x coordinate. Since the hypotenuse is 1,
Oh my
so it's
gosh.
1/2. Can you find the rest? What's the tangent?
Yeah, I want to know.
Thanks.
Okay.
Split.
can still hear you.
Wait, do you divide?
Well, they're not paying as much attention
I know
to
the
my
difference
voices. Not funny.
Right here. But then he said he doesn't want that one. So,
Yeah, Heidi, what'd you get for your tangent?
I got the square root of 3 over.
Stop. Just, I got the square root of 3. Yes, you're right.
Okay,
It's the square root of 3.
What?
can I know why?
Yeah, isn't tangent y over x?
Yeah.
Or in this case, it's going to be, where's my answer? So it's going to be the square root of 3 over 2 over 1 half.
That's what I had.
Well, how do you divide
Flip
fractions?
multiply.
Flip and multiply.
You'd also-
2's
Oh,
are
so the
gone.
square root of 3 over
It's the
what?
square root of 3.
You're so smart like that.
Brenda, you got the cosecant?
no.
Why not? Jeanette, you?
Yeah, I do.
That's not acceptable.
You can't have a square root on
Yeah, you can't have the square root.
So you have to do this. This is yours.
Good, Isabel. Yeah. This is theirs, it'd be 2 over the square root of 3, but we don't like that, so we have to multiply by square root of 3 over square root of 3, so it's 2 root of 3
Did
over
you see one
3.
that was just like on the
Dumb.
No, it's the has an angle in it.
My back hurts.
Pedro, you got the secant?
Not yet.
I think I'm just making.
Oh, what the heck, I put 2 over 1, I'm retarded.
Which is 2.
I know.
So did I.
Is it still the square root of 3?
Yeah.
Oh, 3?
Cotangent?
It's the
Yeah.
third root of 3 over 3. I mean, the square root of 3 over 3.
So you'd be 1 over the square root of 3.
Times the square root of 3.
Over 3. Of the square root of 3.
What the frick did you just say?
And then you multiply them, right?
Yeah, 1 over square root of 3 times root 3 over root 3.
You have root 3 over 3.
I did that way different and got the same answer.
Okay, that's fine.
Oh no, I just took the answer for the other one.
E.
Root 3 is so
Is, what's the square root of 3 times the square root of 3?
and that's one that's just 3.
Yes.
So square roots times each other and cross.
Well, unless it's like square root of 2 times square root of 3, then it's square root of 6.
Oh, I did the same.
But this is square root of 3 times square root of 3 is square root of 9, which is
Hawkins, I'm confused.
Huh?
I'm confused.
about.
I don't know. Wait, how did you get the other ones?
These
I
all
get
over here,
these over here, but not those.
you just flip these. Like, this one's easy to see. If you flip a half, you get 2.
Yeah.
This one, you get 2 over the square root of 3, which
Okay.
you're not supposed to have square root on the bottom.
So you multiply by
So
the.
we multiply by square root of 3 over square root of 3, because that's 1. And then we go 2 root 3, square root of 3 times square root of 3 is 3.
Oh,
So
right.
that's all right. Same thing here, this would be 1 over the square root of 3, but we can't have square root on bottom, so we multiply by root 3 over 3.
Oh, okay. That other stuff confused me. The 3, I don't know what that was. The square root of 3 over 2 times 2 over 1, and then you crossed out 2.
Oh, this was for tangent. Tangent is opposite over adjacent, right?
Mm-hmm.
So think about the triangle. Opposite would be root 3 over 2 over 1 half.
Oh,
And then, so I had that. Well, the way you divide fractions, you flip and multiply, so I just kind
oh, okay. Got it.
of. Okay, do the same thing, but now for theta equal to 7 pi over 3.
Is it still,
7 pi over 3.
That's not right. You have 7 pi over 4.
They're not funny, I
I
don't
know.
like it.
Hello.
Uh-oh. Where's 7 pi over 3? It's not.
Why would you use that one?
What?
7, 5, or 6.
No, that's not 7 pi over
You just tell us, I'm not here to figure out your
I'm
whole
play games.
calculus games here, because I don't,
3. This is pre-calc, sorry.
whatever.
What do you see, how many times 3 go into 7?
2,
2. What's special about 2 pi?
it's the whole thing.
It's the whole thing. So where is 7 pi over 3? If you go all the way around, that's 2 pi, or 6 pi over 3, plus another pi over 3. These are the same.
Oh, Jerry.
These angles are coterminal angles, or they stop in the same spot. This one just goes all the way around the circle once, and it stops in that same
So
position.
it'd be the same exact answer.
It'd be the same exact
You're
answer.
mean.
Same thing if I went 13 pi over 3.
You go around twice.
You go around twice.
And a half, or a quarter, or
Anytime you add 2 pi to an angle, you get the same angle. You just go around the circle again. So like if I said, oh, find pi over 2, you could do it all. Then if I said, now find 7 pi over 2, it's the same thing, it's just around the circle full time. If you're good at fractions, you see that 7 pi over 2 is exactly 2 more than pi over 2. Oh, no, no, whoa, I didn't say
I was
that.
like,
No,
that's.
Oh, yeah, 5 pi over 2.
Wait, 5 pi over 2 and pi over 2?
Yeah, 5 pi over 2 is exactly 2 more than pi over 2.
Yeah.
4
Oh, yeah,
pi over 2.
Okay.
Yeah, it's 2 pi.
Sure.
I even confused myself, don't feel bad.
I don't.
Do you understand the idea of if
No,
you
I
go
don't
around
see
more
it.
than once? If you go around, like we said, you measure angles starting from here going this way, right? Positive angles. Pi over 3 is right here. 7 pi over 3.
So it goes by in 2.
There's 6 pi over 3, right? A full revolution is 6 pi over 3.
Oh, which
What's
is
6 divided by 3?
2.
So now I need another pi over 3, so I'd go and I would finish.
Order is 2 pi.
Each full circle is 2 pi, yeah. This
How are you
is,
getting 6 of that?
huh?
How are you getting 6 of that? Because it's 6 pi.
Over 3. I'm just getting a common denominator.
Like he was saying, like how many times?
Come on. Don't smile.
Yeah. 7 over 3 is 2 and 1/3, isn't it? So 2 pi is all the way around, plus another 1/3 pi. Boom, you're back in the same spot.
I'm not like this class.
Makes sense now?
I'll figure it out.
13 pi over 3. 3 goes into 13. 4 times with 1 left over, so 4 1/3.
Which is the same thing.
2, 4, and 1/3. I'm back in the same spot.
I understand.
So it goes by, it's either
I
it's
just-
2 times bigger or
I just
3
thought
times
it when he
plus
said-
the 1 pi to go back to the beginning.
So like, if I said here's a 5 pi over 4. Find all those, another angle that's the exact same as 5 pi over 4.
Would be 1, would be pi.
8.
Over 1.
Add 2 to that.
It'd be pi over 4.
How do you add 2 to 5 over 4? You add 8 over 4. So the same one, it'd be 13 pi over 4. Those two are the same. Stop in the same position. If you just keep adding 2 pi, it just goes around the circle an extra time, and it'll stop in the same position.
Oh, there was a 5 pi.
I'm banned, Jonathan.
You dig?
Yeah.
I don't dig.
All right.
Alright.
All right.
You like?
We're going to do a couple problems from the book.
It's got weird.
Yeah.
1.6 and 9. This is 1.6 number 9. It says, find all the trigonometric values of theta with the given conditions.
What page number are you on?
1.6.
sit down. Good.
51.
Thank you.
Whatever. I was like, I mean,
Like,
Smart aleck, you lately. He just didn't get a beanie for a couple weeks.
Oops, I should have equal sign there somewhere.
1.6.
These desks need to be bigger if this book's so huge.
So I got the cosine of theta equal to negative 15/17. Given that the sine of theta is greater than 0, find the sine of theta, the cos of theta. Well, we're going to find all 6 things.
How does it,
And this,
Don't you mean cosine for the greater than?
you know this one. No, it means sine. I'll explain why in a second.
Okay.
All we know is the cosine is negative 15 over 17. And we got to find the rest. Do you think this is going to involve the unit circle?
Probably.
Yeah.
Cosine is adjacent over hypotenuse, right?
yes.
Yeah.
So our adjacent's going to be 15 and our hypotenuse is going to be 17.
Then no.
It's not the unit circle, but it's got to use kind of the same ideas. Good job, Heidi. Good job. These are easy if you draw a picture. Draw a picture of a right triangle who has a cosine of negative 15 over 17. Now, I don't want you to struggle too much, so I'll draw a picture, right? But you got to kind of think unit circle-ish. If I draw my triangle in quadrant 1, will my cosine, if I do, here's my angle, will either of these numbers be negative?
No.
No. So this isn't going to work, is it, my picture?
Mm-mm.
I need a negative 15 on my adjacent.
why did I write it down?
Adjacent's going to be like down here, right? So I need that negative, so don't I need it
So
to
you
go?
flip it over the Y.
Okay, so flip it over here. So there. This
Please
might,
tell me that was right.
this
Yes.
might work, I don't know, we gotta
Yes,
check.
it is negative 15, 17.
So this side would be, this coordinate would be negative 15, so that's adjacent, my hypotenuse 17, okay, does that work?
Yes.
They told you right here, the sine of theta needs to be greater than 0. Sine is opposite over hypotenuse, right? So my opposite is positive, and my hypotenuse is positive, so this does work, that's bigger than 0. Because you could have drawn the triangle down here, and still got cosine. If you draw it down here, you still get the cosine is negative 15 over 17, but now your sine will be less than 0, and that's not what they want.
How if it wouldn't it be negative 17?
No, because all you're going by is that point. The length of that side is still only 17.
Oh,
The only ones with positives and negatives are right on these
the X.
legs. Yeah. X and Y can be positive. Because that's really not negative 17. That's like it's at an angle. You can't-
Basically, it's absolute value.
Yeah.
Okay.
So that's kind of tricky. It's kind of weird. So now that we have this drawing, we can figure these out. How long is that side?
What side?
This side. You know, this one's a non-calculator problem. I looked at it, I was like,
15 squared
Yeah.
plus b squared
Pythagorean theorem.
minus 149
You know me.
squared. I'm kidding, I don't know 17 squared.
the one I gave you in your homework, you should know it.
Oh, 289. Wait.
The 12 is 1.4.
On the homework, are we gonna have to do like things like that right
Remember it? You want me to do that real quick?
here? No.
How'd you get 8 over 8? Holy crap.
Because I looked up the answer and I remember.
Cheers.
It's negative 15 squared plus b squared equals 17 squared. So that's 225 plus b squared equals
289.
289. So then you subtract b squared is 64, so b is 8. So now, easy deal to fill in the rest, right? Your sign would be 8/17. So that was the hard part, drawing the picture and figuring out the third side. Why the confused look?
-8 for tangent.
Ah,
That's the fact.
15 is negative.
Oh, you just put it on.
Yeah.
I just put it on top.
Your battery's low in the iPad.
About so. 10%?
Yeah.
Yeah.
That's okay, we'll live. I'm gonna hit 5%, then we're in trouble. Okay, one more. One more like that?
Sure.
Thought houses. Deep breakdown. Over. I know, I probably would have known that class.
It's not even to like the math analysis because they
Which is what you guys should.
don't.
Like us last.
We learned
Well,
You know,
Mr.
think about Mr. Ross.
Who's that laugh like?
It's actually me.
Huh?
Well,
Who's
Mr.
that
Ross.
laugh like?
Oh my gosh, do you have to do the inverse? I don't even know how to do that.
So why do you guys look on like that? We're barely getting started.
He's just jumping the gun.
No.
He's a fighter.
This one tells you again, find the 6 things.
What's up? Girl on fire.
Takes
She
longer to
totally
write
said
it.
that in English, yeah.
Seriously. I know, seriously.
6 things?
Yeah, like, yeah, he's right. How do you get inverse again?
Inverse sign of 8/17. Well, in this case, what are you trying to do? You're just trying to figure out these, right? Should we draw a picture?
Yeah.
We sure should. How can we draw a picture though? All we know is that we know the angle equals the inverse sine of 8/17. Uh-oh.
I don't like that sound.
What are we gonna do?
Hope and pray that God shows us the answer.
I'm
Try
just
that
gonna
as
be
well.
like, copy people and just pray for everything you just pop up.
Admin, please.
But I
Did you guys follow it?
Yeah.
The book, that we're reading the first book,
Yeah.
Raining Gold, all they do is pray.
Just given this, you should know the sine of theta.
They'll pray.
I'm gonna have to
The faith is strong.
If theta equals the inverse sine of 8/17, isn't it true then that the sine of theta is 8/17?
I wanted to say that, but I don't.
Take the sine of both sides. Sine of theta, sine and inverse sine are opposites, they'll cancel out. And the sine of theta equals 8/17.
Okay, I didn't get it. What?
Just like back in the day in geometry, if you had a triangle,
You think I remember geometry?
I know.
I barely
That was
remember.
freshman year.
Did you say butterscotch?
if you had that triangle and I said solve for theta, you would go, oh, opposite hypotenuse, sine of theta equals 8/17. Oh, I gotta solve for theta, so I inverse sine both sides, and I have theta equals the inverse sine
Oh.
of 8/17, and then you type that into your calculator, right? So if the inverse sine of theta is 8/17, so you go backwards, take the sine of both sides, then the sine of theta must be 8/17.
Man, it's finally come full
So
circle.
it must be
So what-
both positive, so it's gonna be in the one quadrant.
Quadro.
And how long will this side be?
15.
15. Yeah,
Is
it's a
this the same as the
Pythagorean.
last
Oh,
It's a
one?
Pythagorean triple. It's the same as the last one. 8, 15, 17. Give me another Pythagorean triple.
3, 6, 9. No.
4,
I mean
3,
3,
4,
6,
5.
3, 4, 5.
Yeah.
1, 2, 3. Just kidding. I'm totally.
No, 6, 9.
3, 4, 5.
Say what?
I don't know.
5, 12, 13's another.
I forgot all of them.
Isn't there a one?
Pythagorean triple thing, what are you talking about?
3 numbers that satisfy the Pythagorean theorem. A squared plus b squared equals c squared. If you want whole numbers that satisfy that,
Isn't there one with the 3?
there's only certain ones. Like 3, 4, 5. A 3, 4, 5 triangle works because 3 squared plus 4 squared does equal 5 squared. It's 9 plus 16 does equal 25. But it's hard to find numbers that make that work. Like you can't just pick random numbers. Like 3, 4, 6 doesn't work. 3, 4, 7 doesn't work. Nothing else works with 3 and 4 but 5. Another one is 5, 12, and 13. Because 5 squared is 25 plus 144 does in fact.
It'll take a little learn.
Those are Pythagorean triples. Just 3 numbers that make it true.
Triples.
8, 15, 17 is another one. That's, I can't name any more off the top of my head. So now that you got your picture, the rest are easy, right?
Yes.
No?
Honestly, I have to write out that little thing right there so I can.
So Katoa?
Yeah, I have it right here.
Yeah, I have to rewrite every time where I get confused.
Or I have to send it out.
Yes, so, opposite over hypotenuse.
Cosine is 15 17.
Cosine is 15.
Tangent is 8 15.
Why?
Just
Rest of
17
it.
8. 17 15 15 8.
Just watch it when you go home and I'm gonna put me in my mouth. I like when you give us time in class to do our homework.
It's not looking good today. Okay, next thing, pretty easy. I think we even talked, just converting from radians to degrees and degrees from radians. Just kind of filling in a couple things here now. We're kind of stopping, like, we're not really advancing. Just